We can traverse lists in ways similar to the ways that we can traverse strings. So here's a couple of examples. In this example, we're going to first traverse it using the notation, the for loop for n in numbers, and then we'll look at it again when we actually traverse it by indexes. So let's execute the code and see what happens here. So we assign a list here, and then as we traverse it, notice that we go through, and it's just doubling each element of the list as we go through. But notice that in printing it out. So 3 times 2 is 6. 2 times 7 is 14, and so on. But notice as we go through the list, n is the loop variable, and n is separate from the list itself. So each time we go through the loop, n is assigned a value, but it's not part of the list itself. Let's continue on. And so notice that as we change the values of n, it doesn't actually change the values of the list. So the list remains unchanged. However, if we do want to do something that changes the elements of the list as we traverse it, then we need to use this indexed notation. So instead of just getting an n from the number itself, we actually get the index values, and we use that to index through the list. So here, notice that the I is going to range from 0 to whatever the length of that array is, of that list is. So first time through the list, I is going to be 0. And now, notice what happens when we execute this line. It indexes into the 0th element of the list and doubles it. And then it prints it. Second time through, I will become 1. And we will double the second element of the list. And so on with the third element of the list. So that by the time we're done going through the list, we will have actually changed each element of the list itself. So which pattern you use, which approach you use, depends on what you're trying to do. So in this example, which uses the accumulator and to use a reduce pattern, in this example, we use the first because we're not actually trying to change the list itself. In this example, all we're doing is we're totaling up the sum of all of the values in the list. So the sum of 1 plus 2 plus 3 will be 6. So let's visualize that and walk through the code. So here we define the code, and it creates a reference to that function, add all. And then when we assign a list, and then we call the function, notice it passes a reference to that list, to the function. So here's something to note is that when you call a function with a list, it actually passes a reference to that list. So if you change that list in the function, it's actually going to change the list globally. That's different from regular scalar variables. But let's keep moving on. We'll initialize the total to 0, and then we will start our loop. So x is the loop variable, and as we go through, it'll add x plus the total. And then the second time through the loop, it'll update the total. Third time through the loop, it'll update the total. And then it will return a value of 6, because that's what is in total. Notice we didn't actually change any of the list elements, so that didn't change the list. And when we continue on, it'll return, and it prints out that value. So that's an example of traversing a list and using an accumulator. That's what we did with the total variable here. to keep track of something. In this case, it was just a simple sum, but it could be more complicated. And the whole effect is to reduce the list from a list down to a single value, which is why we call it the reduce pattern.